Here we are. Hello, ladies and gentlemen, and welcome back here on the industry stage at Formnext 2024 at our panel regarding AI. So this panel explores the integration of artificial intelligence and the industrial metaverse into additive manufacturing. It delves into how AI-driven design optimization, predictive maintenance, and quality control are enhancing additive manufacturing processes. And additionally, the discussion highlights the role of the industrial metaverse in creating immersive digital twins and virtual environments that enable real-time collaboration and simulation, leading to more agile and responsive manufacturing workflows. And I tell you what, I'm not an expert, and this is why we got some experts here to the stage. Let me introduce them to you. So, to my left, Gustavo Melo. You are well known, Gustavo. Nevertheless, you are group leader for Industrial Metaverse at the RWTH Aachen. So this is your main topic. We talk about that later. Yep. Then we have Sebastian Heinz. You know him already from the very inspiring and scaring presentation. Don't get me wrong, Sebastian. So you are founder and CEO of StatWorks. So you are a consulting firm specializing on artificial intelligence. Yes. And then new to the stage, Huber, with the most fantastic name, Huber. I hope I pronounce it correctly. Hörampoli. Is that correct?
Well.
That sounds fantastic. So you are CEO of Gravity Pull Systems. We heard a little bit about it in the speech of Andrea, so we step deeper into that topic. And last but not least, I'm glad to have you back on stage,
Thank
Anthony.
you so much.
Anthony Lillet, big applause so for him as well. Founder and CEO of Automation Acoustics. So we dig into that topic as well. Thank you so much, and a big applause for the panelists here.
Thank you.
So, I tell you what, I prepared for the topics, and the thing is, you can't be prepared. Yeah, that's impossible in my opinion. So the first thing I want to do is to hear from you, what is your stake into artificial intelligence and what is your kind of definition, because Sebastian delivered some different definitions, or let's say levels already, and I would be interested, where do you see yourself in your work right now from the maturity level in your artificial intelligence work? Gustavo.
So Zen, thanks very much. Thank you very much here for welcoming me here in the panel. Well, in Aachen, we are really mapping now the possibilities of AI along the process chain of additive manufacturing. Yeah? We're having now some studies made in the ACAM, so the Aachen Center for Additive Manufacturing. We covered design part, the process, the quality assurance, then we kind of map it to understand what is the potential there. But we realized that additive manufacturing is a kind of great base, since additive is quite digital. Yeah. So from this additive, let's put like digital perspective of the manufacturing, you can already collect a lot of data, and this data is quite helpful to be used in additive as well in artificial intelligence. So the point for us is mapping right now, and then we understood that we can apply not only for the process chain, but also for the value chain. So now we are now understanding and applying artificial intelligence to map, for example, customer interest, also to mapping the skills that are needed in the market, and then to try to understand where is the direction that we should go for the development. Yeah? Caring for the design, using AI to accelerate the design. Yeah? Going for the process itself, understanding how to apply the data they collect already in situ process monitoring to discover the defect root cause. Yeah? And last but not least, covering the part of qualification and see, for example, using of AI to map and analyze microstructure, for example.
Very good.
Yeah.
So we skip you, Sebastian, we take you the last, don't get me wrong. Huber, what is your part in AI? I mean, we heard you are kind of have already an offering, so what are you exactly doing?
Yes, Andreas, I think, explained pretty well our AI offering on the metal printing side, but I think if you talk about the metaverse, I have a better example which probably shows the opportunities and the challenges of AI combined with the metaverse. And this is maybe just indirectly connected to the AM industry, because one of the applications in a medical application where we AM print biosensors for diagnostics, and we are a member of the HEART project, the HEART, so-called HEART, which is representing the digital twin, which is actually a core component from AI metaverse combination. it's representing the heart, not just the model of the heart, but how a heart is working. So the huge advantage and opportunity is that, for instance, if you have like a new procedure to treat diseases, you can simulate the heart disease, and then you can simulate the treatment of the disease, all the diagnostics, and draw conclusions, what is working, which is not. But this is the big opportunity, because of course, we don't have, and probably it's a not good word, we don't have that much waste, we are talking about a human body. It's not a waste, of course, but you don't have to really touch the heart and do different things in a physical heart, but you really have the digital twin is working exactly the same, hopefully. So the big opportunity is very clear, but what are the big challenges? The challenge is, of course, that this digital twin has to have a very high fidelity, because the high fidelity is actually an assurance that whatever you get out of this model is going to reflect the real world. So if the AI reaction is not so-called correct, that can have a very serious or even fatal consequences. You don't even know, is that the side effect, what has been generated, is the real one or not, or is it working or not working? So this is one component. And the other component is, most of the project is, of course, the AI part, because the model and the working, what you see with your different devices or the PUI, is just actually the tip of the iceberg of the AI data and the AI model. But how do you know that the AI model is correct if the AI model is a black box?
That's right.
So this is going out so-called responsible AI or ethical AI. So what is my way of making sure when I'm treating or diagnosing patients with a heart disease that it is really the right thing? That's what we're doing here.
Oh, let's
keep
that
questions.
point. Yeah, we're coming back to that later, because a lot of friends of mine are doctors, and if I talk to them about anamnese, it's very interesting how they approach it, and it's pretty similar to AI, I think. So, Anthony, I mean, I remember your speech when you presented your company, and I remember it's very much focusing, I think we called it machine learning and not that much AI. Nowadays, we would call it AI, right?
Yeah, that's correct. And I guess we use the machine learning at a real-time level. It's all the AI is how we actually look for the patterns. So for us, it's a powerful tool to identify and associate errors and defects that occur from the acoustic emissions and how they correlate with process in real time. So the most important for us, it's just a tool. It's a tool for us to look for these patterns that skilled operators can usually hear, but now in an AM space, you're in closed boxes, you've got micro welding occurring, you've got all these other behaviors, but you can't naturally hear. So the AI gives us a depth in our full spectrum to look for these patterns, associate patterns, and then find other things of high value that our customers say, gee, we didn't know that. Yeah. So for us, it's a tool. We keep it in a black box. You're absolutely right. At a operator or at a deployment level, it's the machine learning models we use as an output from our AI. So we separate it into a couple of different groups in how we use it and deploy it.
Very good. Sebastian, coming back to your speech, I mean, we were talking about the levels, and it's like the narrow models we are using right now, and still exploring. I mean, starting with you're exploring it. Huber mentioned a very important point. You don't know exactly what is inside the AI. That's sometimes threatening me, don't get me wrong. So, I mean, you have to use a certain model, and you need a lot of data, right? I mean, if you want to simulate a heart, or if you want to simulate a print, or even if you want to analyze the acoustics, you need to know what is a good and what is a bad acoustic.
Right.
I mean, if you don't know that, the AI wouldn't help you. Yeah. So, how do you generate a model that would help the others? What is the process of generating?
Yeah, so I mean the process of building a model is actually pretty straightforward. Actually, for like 90% of all machine learning models, so you need training data. And you need some kind of quantity that you want to predict. So for example, in your case, you have like audio data, and you can associate all of those samples either if it's a defect, yes or no, right? So this is one of the simplest part of machine learning, like discriminative models. So you take data, and the AI/machine learning model is basically classifying them into different groups. So this is one of the most straightforward cases. And actually, this is also the system that ChatGPT is relying on. So if you take that, like ChatGPT is taking patterns of text, and it's actually like predicting the category of word that's coming next, right?
Yeah.
And you really, if you double click on most of the AI models today, you see that this is the systematic that most of those models are working on. And dependent on the task that you want to solve, you have different kinds of data sources, right? You have audio data, ChatGPT uses text data. If I want to predict sales, I have my sales data, and so on and so on.
Exactly.
Yep.
And this is also, I think you mentioned that he said it in his post. Actually, if you take the word of AI, like 99% within that word is machine learning, right? And we just associate all of the machine learning models now with artificial intelligence. But at the end of the day, it's still machine learning. All of the, or most of the techniques are pretty well known and developed over the last 50 years. But right now, like with the generative models, we've basically established a kind of new class of machine learning model that for us as human beings has the appearance as if there would be some kind of intelligence behind it, right? Yeah. And if you take a closer look and double click on that also, you see that it's actually not very intelligent in the human sense, but it exhibits some kind of properties of human intelligence. And this was also what I was mentioning in my discussion, that the human intelligence is basically a multidimensional concept, and it has, for example, the ability of pattern recognition, right? And many of the machine learning models can take that ability and be superhuman good at it, right? Yeah. And I think this is the interesting part also of the discussion. When it comes to artificial intelligence, I think it teaches us also a lot about the human intelligence. But I'm very, very sure that if you would like also maybe think a little bit into the future, where you have kind of a like general AI or AGI system, it would probably have nothing to do with how a human brain works. And that's okay, because at the end of the day, it's a tool, and we can use it for our purposes. And that kind of intelligent behavior that we are looking for is probably constructed in a completely different way than compared to how our human brains operate. But I also like to bring one example here. So if you want to build a machine that does something similar, like you see it in the nature, for example, you want to build the fastest running robot on the planet, you take a look at, I don't know, cheetah or like a gepard or whatever, and you build it, right? It has 4 legs and it runs really, really fast. But you could also take 4 tires and put on a jet propulsion engine on top of it, and would go with 1,000 miles an hour through the desert. So it does the same thing, but it operates in a completely different way. And I really like that anecdote when you compare it also to intelligence, right? So there's no need that an AI system must work in the same way as our human brains are to be better in what we are calling human intelligence.
Gustavo, Sebastian mentioned data, so you are exploring the industrial metaverse and how to apply artificial intelligence in additive. So where do you get the data from? Because I mean, with Huber is clear, with Anthony is clear, because they have a specific topic they're working on, or let's call it a focus, yeah? So, but you are looking in a broader range, right?
Exactly.
So are you cooperate with companies that delivering data? Because as we just learned, without data, no AI, right?
Yeah, definitely. I mean, what you just mentioned, additive manufacturing is quite rich with data. Yeah? So then you can start from the design itself. Yeah? When you're already designing, we do a lot of simulations. This simulation is already one type of data that we can use to be and use in AI, or use AI in combination with simulation. So the simulation can take a really long time, and then we apply AI to accelerate the simulation results to target that. This is one application that we see in design and in simulation combined. Yeah. When you go for the process itself, there is a lot of data collected already by the machines. Periphery, temperature, environment, even the noise. We always make like an adult. You interview a robot, like a microphone. In additive, this interview has already been made. There's a lot of interview data there, and then it's not being used. And that's the point now, kind of a call for many companies. It's kind of the AI has been used to improve the productivity, because their markets have been already starting getting red, a lot of competitors, and now is the point of improving performance of machine regarding cost, regarding sustainability, regarding also quality of surface quality. There's one point that is always described as an issue in AM, right? And last but not least, what we call post-processing. AM is not to be alone. AM is a combination with a hybrid, it's a combination of conventional. So then it's kind of work together with institutes as well, companies that have good experience in the conventional manufacturing. There is a lot of information, there's a lot of knowledge that being applied in conventional manufacturing.
Yeah, my question would be, and who are probably your experience, are they willing to give the data? So I mean,
No.
you had a cooperation now, and you know what I mean. So same with me. Don't get me wrong. Let me be the naive guy here on the stage. Yeah, you give data into ChatGPT, for example, and I clicked. Of course, I don't want to be part of the learning process because I thought if I do that, of course they will get my IP inside a model, even if it's in a model and it's mixed with 1,000 other things, but I give it in, you know? So what was your experience when starting with AI?
So our experience is very mixed, but basically you are absolutely right. Actually, when you're saying, big question, do you get the data from earlier experiences? That would be actually the idea, that you can merge different experiences like a human evolution. One is actually, I don't have to learn again, you know, how do different things which 1,000 years ago people already figured out. So the same thing with AI. But at the moment, I mean, how should I say, the culture of the AI is still what you just, I'm trying to explain. Much of our successes was very limited to a corporation or like to a larger, how shall I, ecosystem where you have multiple partners. And don't take me wrong, the benefit is still huge of AI, even then. Of course, it would be much, much bigger if you had, like, you know, the buy-in from so-called like non-participants, not direct participants, but someone who already did that, the same project. So so we have another system, which is another good example. This is an optimizer for optimizing processes based on AI data, and then very complex systems or very complex processes, so to say. So with simulation capabilities where different variations could be really just mind-blowing. It's just no way a human mind can just really see everything immediately. So that's I like to a little bit extend this discussion to the metaverse. So our thinking was how you can really present the different type of options as solutions, because you have the AI as the data, as you just explained, or the different pattern matching and how this works, and with the machine learning. And sometimes the result is overwhelming, not just the data. So how you present this, you know, to the users. And then one way we've been experimenting different things. So one is like creating a 3D view of the process, whatever the process is, whatever the problem is, that you have like a visual input, a visual presentation of the results. But then, and then you have very different technologies to do that. You have the different goggles and these kind of things. But so my personal experience, and many of people I'm talking to, they are still a little bulky and not very convenient. And then you have to have maybe cables. No, this is not like just you are just walking around your physical world with something else. So we switched to something like a holographic experiments, which is basically you have no device, just different sensors and the combination of different sensors on the surfaces. You try to generate a holographic view of your real physical world and the result of the AI, whatever it is, combined like the effect on the physical world. But the technology, I think, still not quite there. So it is like either you have a very complicated infrastructure in case like the holographic situation, or you have something which is not really convenient, or even you have sometimes the feeling you are not even part of the real world and you're losing, the connection to the real people.
To the real product, yeah.
So those are still, I just summarized it, technology is not quite there, but I think this is the most interesting part. One is, because I think the software side, we always figured out something very quickly. The software, or we will figure it out. We have so many different methods and ways, to slice and dice the data and find the correlations, the matching, and so on and so on. But how to make this actually very practicable in the physical world? Like, for instance, my customers. Okay, I have this very, very complex process. What should I do now? Okay. And then you have still zillions of options. And how do you know which one is the best? Because you also have to make the decision as a person, not just saying, I cannot say as a system, this is always the best. I want to give you the option to say, overwrite it, what the system thinks.
I totally agree on the whole data front. I think your word focus gives us, in some ways, a great advantage, because focus allows us to understand the problem of our customer. And when you understand the problem you're trying to solve, then we collect good data, not big data.
Okay.
And it's a bit of an expression we have internally, because if you get lost in big data and it's not relevant to the problem you're trying to solve, you're just wading through things that aren't contributing to the bigger picture. So how we collect data is just as critical as how we process the data. And that ability to get that from our customers is actually part of the relationships. And so I think over the last 7 years, we've been collecting acoustic data. We've been labeling it as we go. I think we've now ended up with the world's largest acoustic labeled data set for AM, I think, and a lot of other subtractive processes as well. But in doing that, we've been able to put that into our models. And so it's a sort of collective knowledge that is coming from various sources that are all kind of adding to a greater outcome in the models we generate. But without doubt, we've got to be very careful that we're not polluting it. And how are we working with it? How are we questioning what we're getting? And many of our tools internally are also qualifying the outputs. So how do we actually validate what we're getting? How do we... Is that a false positive? Is that something? And how do we confirm that against an audience that may not understand? Or they have no other secondary checking qualification process to say, well, we found something, is that true? And they're like, well, we didn't know. And as we learn on the journey, we've discovered tools that we've got to work with so we can engage with our customers, so they can guide us on their knowledge. We always say the most important and most powerful person in a room is the person standing in front of the machine. They're the ones who feel it. They smell the machine. They listen to the machine. They know it. And it's one of the more important things for our team is to actually spend time watching the machine, watching the behaviors, the operators, and then building that bigger picture so that when we label, when we interrogate, when we qualify our models against the actual and the real world, there's substance of relevancy to the problem we're trying to solve.
This is funny that you mentioned that with the focus. So that would be the issue. So you mentioned it a little bit where you say, today we are at the stage, they are the one tools that can process pictures, the one that can process audio. It's not that mixture already in place. That makes it quite difficult if you have different parameters you have to look at. How to combine that, that would be my question. So let's say you want to check acoustics, you want to check the visuals, probably temperature. How do you create such a model?
Exactly. So this is also one of the, let's say, big discoveries. I would not say, but like recent advances, that you can actually process different sources of data at the same time in a single model. So that wasn't really possible before, right? So in my early days when I started out, you had like your toolbox of models that could basically only process structured data. There's kind of tabular data like you have it in an Excel sheet or something, right? Then over time, as the progress with neural networks and deep learning, accelerated, then people started to process image data, right? And they found ways of how the models can basically look at different parts of the image and then maybe classify it and blah, blah, blah. And then over time, and right now we're at the point that the models can basically process arbitrary data inputs, be it tabular data, be it image data, audio data, video data, and so on and so on. And there are already, which I find pretty interesting, companies, for example, that try to model smell, right? Because smell is basically just a chemical compound that you can then transport and transform into some kind of data structure, right? And the new generation of deep learning models offer you the capability to include any kind of data source into a single model and then to predict some kind of behavior. Maybe if the machine smells funny, that might be indicative for a defect or something like that. And But this is then not what we are seeing with the generative models right now, because the generative models are basically so-called world models. So they try to understand the world as a whole. Let's put it like this, right? And you cannot just throw in the audio data from the machine and ask if it's broken. This is not how the model is constructed and what it's operating for. However, and this is what I mentioned also in my talk, we see that kind of convergence of models where you basically have a single large model that can process arbitrary inputs, and then with a limited amount of labeled data, for example, you can basically refine it and tailor it to your specific use case. And this is probably the next generation of large foundation models that we will see, like so-called multimodal models that can take arbitrary input at the same time, and then with only some kind of labeled training data, you can tailor it and fine-tune it to your specific use case. So this is probably something that we'll be seeing also in the next, I don't know, 3 to 5 years. Yeah.
And then would probably enable us to check the data as well. So, I mean, you, of course, you're an expert in audio, and you can see the graphs, and you know exactly what this should mean if you work together with your client. But then if you go into the, let's say, multiverse, where you bring this all together, you can, if yours labeled, you can recheck it to other labeled audio, for example, and get it into a perspective. That would be the way.
Exactly.
But Gustavo, let's stay a little bit with the checking of the model, because Anthony brought up a very important point in my opinion. So that's what I always think, and that goes along with what you said with the heart. How do I know that the model is representing the heart correctly? Yeah. So if you get all the data, I mean, you cannot be expert in everything, even not at the RWTH. So you get the data. How do you make sure that the models developed are reflecting the reality? This would be my question. Is that something that you deal with, or?
Currently, generated labeled data or testing, generated really with the physics, because many of the data they're collecting and they're looking for is physics-based, right? And then you're really using the physics principles and collecting and label the data afterwards, make this fine and cross-check. One thing that we're looking for the future, since we're also a research institute and saying like in the long term, and there's a lot of discussion now, how could quantum computing help in this into cross-checking, like breaking this black box? It was also something that I would like also to put here in the question, also put in the round, because there are a lot of discussions about how quantum computing could support exactly to understand machine learning, understand deep learning, understand how the data is now be processed inside, to open the black box. That's something that I would like to also put in.
As to my understanding, there are different ways to, like different methods to test. The problem, at least what we also tried one of these things, but the problem what I'm seeing is testing the validity of the AI model takes more time and money than create the model itself.
Yes, that's
this is today the problem. And then you're talking quantum computing, that's probably the solution. I don't know.
But that was my thought. I mean, if I need to do the testing, then I can skip AI and do it right away with the testing, right, Anthony? I mean, this is probably how you started. I mean, you needed to collect data. So in the beginning, you got the sound, and you compared it to the results. And you say, this sound means defect, this sound means okay, basically.
Simple.
Simple as that. So how can we... how can we prove that the model is correct without doing this extensive testing that would make it obsolete?
Yeah, you cannot really do it, and that's exactly that's exactly also one of the interesting concepts around AI. So you mentioned that basically we are using physics and kind of mathematics to describe the world, right? So this is a tool that mankind has developed in order to understand how things are working in the real world, right? Machine learning is also something that can mimic the behavior of the world without explicitly modeling it. So this is a different approach to describing the reality and making predictions about the real world. And the problem is that you cannot really combine the two worlds at this point in time. So for example, I can use also AI to make prediction about the state of quantum systems without ever having attended a single lecture about quantum physics. right? So you can make predictions about the world, you can make predictions about if a machine is broken or not, without the AI knowing nothing about any machine on this world.
Yep.
And this is the big paradigm shift also in AI. For example, also in the sciences, in physics and mathematics, that you have now predictive tools that are so powerful that make better predictions than if you try to model it with the most difficult formula on this planet. And the core idea behind that is that there is some kind of, let's say, underlying pattern behind what we can observe that machine learning models are capable of capturing without modeling it explicitly in a mathematical way. And I think this is a very, very interesting concept to think about because, for example, if you take the Large Hadron Collider in where is it, in Bern or Genf, Bern or Genf, whatever, yeah, right? So you cannot arbitrarily scale this project up, right? We are already at this point that any kind of scientific breakthroughs in that area is correlated with a massive investment, like in the billions and trillions of euros. But we're hitting some kind of wall there. We cannot go bigger than it is right now. However, on the other side, we have now new tools and new methods from machine learning and AI that might be able to predict the behavior of certain kinds of, I don't know, particles or whatever, without explicitly modeling it. Just by observing data, collecting the data, and predicting stuff out of it. And I think this is also a pivotal moment in the sciences, that we might be running into a situation where we enter domains that we cannot really model. However, we can predict it using machine learning and AI. At the cost
by looking at previous results?
Yeah, at previous results, but at the cost of not really understanding what's going on. Yeah. And this is exactly this is exactly what AI and machine learning at this point, and also ChatGPT does. Nobody can really tell you how ChatGPT is working and like the exact mathematical reason why the things are like they are. It's largely unknown. We just see that it works. And I just want to cite one interesting quote of a professor that I've recently watched in his lecture, and he compared the age of AI to the Bronze Age in the Middle Age, because there people discovered metals, right? So they know they have gold, and you have messing, and you have silver and stuff like that. So they have absolutely no idea about the chemical composition of the metals. So just know that it works.
And they look great.
And they look great, and they're helpful for doing stuff. For example, if you have eisen and you make a hammer out of it, you can do stuff with it. It's a tool, and it's helpful for us. And I think at this point we are in a development of AI, we're in the same stage. We know that it's helpful. We can predict machines, we can make predictions about whatever, quantum computing, or just the sales of our products, but we do not really understand how it works. But the question will be, will we ever be able to do that, or are we just reaping the benefits out of the technology for our purposes?
And now it comes, probably, Huber, Anthony. So you know what my problem is, and let me be quite frankly here. So it's a matter of trust, right? I mean, you want, and you're doing it. It's not about wanting.
No, we're doing it.
You're selling it already. Yeah. So, me as a customer, and they are having the same thoughts. And that's a little bit the problem. The customers are not stupid, so they think the same way. How shall I trust the whole thing? Yeah, that would be basically the question, Anthony. How can I give you trust?
It's you're actually I sometimes call it another language. And the language is not the language of AI. It's a language of prediction and confidence. And when you're presenting back information to a customer, you're almost teaching them a new language to understand what we're giving them and how they'll interact with that. And in many ways, it comes back down to what's the action you derive from that bit of information? And who is the person who needs to make that action? So if you're working at the machine level, the operator, what is the information that operator needs to have sufficient confidence to make an informed decision to do something to prevent a critical issue occurring or something going wrong? So you're presenting information in certain ways, and then, so that's a test in many ways. You're actually asking, and we have had to create very unusual ways to build that relationship, to build that confidence that someone says, actually, this is really good. I get it now. I understand what you're giving me and how it helps me. And actually, I want to help you. And so, again, it comes back to the smartest person in the room at the machine level is the person in front of the machine. So that's how we build confidence in what we do, by engaging with them. And we've had to build techniques to do that. Doesn't exist.
Huber, sorry if I interrupt. That's exactly why I asked Andreas, what is the percentage of improvement? You know what I mean? So if I would be the manager, I would ask, I mean, I fully get what Anthony says. So I get the results, and I want to see how much is the improvement, and is it repeatable?
Yes, this is actually our big, how should I say it, selling point. I mean, we had a couple of projects, we had this experience, sorry interrupting you, is that you print at the end. So you have the proof or not the proof. And if it's not working, then we are not customer-supplier relationship anymore. So it's as simple as it is. In our case, it was very easily, because based on the statistics and the proof, we can confidently say we can eliminate 90% of the problems while increasing 40% efficiency. Those are very powerful numbers. In other words, you have 40% less print time, but you eliminate it at the same time 90% porosity. So this is a nice KPI. So we are lucky in that sense. But you are less lucky with a similar problem, what you just described, a little bit similar with our process optimization, as I explained, which is optimizing processes where I have not just one machine I optimize, what Andreas described based on AI models, but multiples in the entire process. Then, it's difficult. It's getting more complex, because it's not just something you print something physical and you see the result and it's okay, you check it or not. But you either save that much money, but what if I had done something else, I could have saved much more money, let's just say. And here you can put in some so-called breaks, or we call it sanity checks. So we didn't pursue the generic procedures of testing an AI system. We put in our so-called sanity checks. For instance, you don't draw something for a resource which is not available at this point in time. You can check that this is at least this minimum. You can assure customer you are not worse off than when you didn't have this system. So that's probably I can offer. And then otherwise, or we can simulate, we tried actually simulate the human thinking. What is possible humanly to calculate if you have these thousands of different options and different combinations of ways to, optimize a process? A human is capable to see this. This is a very simple decision. If I have these things available, I immediately use it, and I don't wait and then try to combine it with something else, just like as an example. Try to simulate it, and this is our so-called baseline, and then compare it with the real result. So those are a little bit more practical, how shall I say it, ways of doing this.
Kind of combine the traditional with the future, and then trying to bring this.
There was actually, I think a couple of days ago, a big study about the ability of AI to predict human reasoning. Right? Because we always think our human decision process very, very complex and blah, blah, blah. But actually the study showed that it was a large experiment, I think with 1,000 people that were basically given a variety of different decision tasks, right? Like different situation descriptions. How would you decide? Would you do A, B, C, or whatever scenario it was? And the AI was basically to learn over a couple of hundred data points to predict the human decision outcome at a, 90 whatever percent accuracy.
That's not surprising for me, because I'm doing leadership, and I can tell you there are some leadership principles, and the reason why we have principles is because we can categorize human beings based on their experience and their seen behavior, and there's the word cliché is like the oldest word for artificial intelligence in a way.
And exactly, that's the point. And if you get an AI system with a couple of hundred data points to a very, very high prediction accuracy, that usually means that the underlying structure and pattern of the problem is very simple. And this is also why ChatGPT, for example, needs billions of data points, because the semantic structure of the language and of the different topics is very, very complicated. So on the opposite, that would mean that actually the human decision-making process is very, very simplistic, and that also reflects the situation that you, I think, described, that if you get too many decision variables, you're out. right? And you as a human, you always try to decomplex the
Right.
situation.
Right.
Exactly.
And this leads
up
to
to 7
situations
facts.
where then, again, with
Or
machine
handful,
learning,
top 5, top
exactly.
3, and
What are the
top
top
5.
3 problems?
Yeah.
That's
maybe
exactly
it's
it.
more complicated than the top 3.
Spot
It's
on.
maybe the top 30, right? But we cannot comprehend
No.
and crunch that information in our brains. And this is exactly where AI and machine learning comes into place. For
Yes.
example, in problems like you are working on, where it's not just two-dimensional problem, it's a 200-dimensional problem, and humans are very, very bad at those kinds of decisions.
It's such a really good point, that top 3 or 4, and it's always where we start, and it's the ones that I can relate to the most.
Yeah.
And then as we introduce the multimodal approach, and because we're trying to got a foot in both camps, we're trying to start at a very basic level to interact, but we're also trying to do these multimodal, very deep things where we bring other sensory components into this. How is that reasoning that we're expecting a person to do at that point in time and at a critical moment? We can actually start to build those logic controls. We can actually guide and inform based on that, and that's where we're sort of having to balance. But it is absolutely a valid point. Start simple, grow from there.
One topic I really would love to tackle, because we are talking a lot about how it's going to work, what are the restrictions, what are the challenges, etc. But let's get an outlook a little bit for the last couple of minutes. So, we've seen 2 of you are using it already in practical things in additive manufacturing. So I was starting with you. What kind of things we can expect to be? It's not the right word to replace humans in that. Let's take design. I've seen a lot of startups already using AI in order to design additive manufactured parts or optimize design, etc. Where do you see the most benefit for AM specific in the next couple of years?
I mean, this combination, I don't think that AI will just cover everything in the design, but it's in the combination of what we called here and described before, Industrial Metaverse, and giving this possibility to cooperate and co-work with the AI. So we have like a design assistance that will be there, even in a co-space, and virtual co-space, that could give the possibility to interact with my client, directly interactions, and supported by AI. So it's a kind of the idea that I see in the future of this co-working, kind of enhanced by AI, but it is still human-centered.
Yep.
Yeah, so this is what the point that I want to emphasize. We're not just killing all the jobs.
No.
We're just using AI to enhance and capable to tackle tasks that are really complicated for us. We're just saying here about complexity. So part of complexity, treating a lot of data, this one areas, layers of combination of variables. This is also because it's exponential. So you just think about linear, no. This is exponential when you start to add data, right? Data points and parameters. So from my point of view, try to go, and AM should go on this direction of enhancing the capability of humans.
Then we need to integrate AI into the AMI navigator that we heard this morning. I don't know, the initiative of Siemens and Co. and Dimension, where they want to guide users into AM, because this would be the first contact point to collect data. What are their needs, how they interact with AM, etc. A very good proposal.
Yeah.
Huber, what do you think? What will be groundbreaking?
Groundbreaking.
Before we ask Sebastian whether it's feasible or not.
I mean, groundbreaking. I mean, from my point of view, at least in my day-to-day business, if you can offer like the magic button and the customer, oh, I'm so happy, I saved so much money, with this system, and I'm so much more efficient and can make so much more sales. I mean, this is simply my satisfaction. And technology is really, really important, and I somehow you feel like in heaven or nirvana when you go all these different models and read them. And at the end, the transition in the practical application, I see that one. I mean, things what we talk about, like checking how efficient the system is, how quickly you have the result of AI. So for instance, in our case, we had to spend lots of time to tune our system so that, you are directly connected to the physical process. You have like an initial result from the AI, but it's probably valid for the next 10 minutes or 15 minutes because something can be very different, goes wrong, so you need the data continuously for the physical world, and then you have to be able to react on it, but you don't have time to wait 3 hours, you know, for all this computation to finish up and make my decision, because now I have to decide what should I do in the next 2 minutes. So I think those are in a practical data applications, that's what I see.
Yeah.
We'd like to see improvement. Yeah.
One point just to add here, optimization of AI. We always oversee one aspect is regarding the energy used in AI. So it's kind of the sustainability aspect of AI.
Yeah.
As a lot of oversee, and then should be also in the point of discussion, yeah?
Right.
Because you have to optimize because of the time, but think about as well what you optimize about the energy that you're investing in putting there. Yeah?
That would be actually an interesting study to see, you know, all the additional energy spent and saved by the way of the results
Kind of life
AI.
cycle
What is your
assessment,
balance?
comparing the AI
Yeah,
use
like
of
a
Would be
life
great.
cycle
Yes,
assessment for
exactly.
AI
Exactly.
combined
Yes,
processes. So,
generally.
Anthony, are you? Let me
That's a
add
good point.
something
Yes.
to the question.
Go for it.
Because you're using it already. So, are you acting as a role model? Don't get me wrong. In terms of no. In terms of, are sometimes companies approaching you saying, "Hey, you're using it already. Can you explain how you use it?" Despite the acoustics, I mean, not specific to your topic, but they say you're using it successfully. How can we do it as well? Is that something that happens?
No, I actually don't get that. You probably notice, even our marketing, we don't use the word AI on any of our marketing. So it's just one of those things. I guess I'm more modest on that front. But I guess from the future I see, it's always going to be the human-machine interface.
Yeah.
That's where I see the most powerful in this area. And it's for a number of reasons. One is we've got AM as a new technology. It's a new application. It's a new space. Most of the skill sets are trying to adopt from more traditional skill sets, but they're still different. And you've got people who have not coming through a training program so much. They're not spending time as apprentices working on the tools for 5 years to become specialists. They're put in front of a machine and they're kind of needing to push buttons, or they're expected to interrogate. They're expected to come back to that reasoning. And from our experience, we've never had a machine that behaves as intended perfectly 100% of the time. So a lot of the machines behave in quirky ways. You're working with powders, you're working with fluids, you're working with things that have uncontrolled, weird behaviors. And guiding an operator to quickly put rationale around how to quickly define or diagnose a problem, guide them in that direction, and associate, oh, that noise or that issue or that thing, oh, that machine's telling me this could be the problem. I'm coming back to faster, quicker, solving a problem, getting the machine back into productive state, getting the company to make money, and goes back to that time issue. I'm compressing the time, I'm not wasting time. So I'm finding things like training being an incredible, interesting area where people, you don't lead with a pitch, hey, we're going to save your training time. But training has been an amazing benefit of the things we do. Guidance on problem solving in complex spaces.
Yeah, root cause analysis.
Root cause analysis. And that's all what I'd probably call in the instant time domain phase. But then you've got the post-die, all the data you can dive into at a later point to say, hey, we've made these 500 parts. Why were they changing over time? Because we see a comparison and a variation. And you start to dig back and you can look at a slightly bigger models and say, oh, this input changed here, or that operator was different to this operator. We've actually seen those sorts of patterns and behaviours come out. So we can guide the strangest insights from information we'd never thought were relevant at that time of working into the situation. I think that's probably the most exciting thing we do when you say what's in the future is the discovery of what is possible from the information and insights we gain, which we don't see as significant value, but our customers go, wow. That's something we can use to our advantage. It makes us a better place to work. It makes us more money. It keeps our employees engaged. They learn something. So these are all very nebulous, but they're really critical and really important to the journey ahead. So again, I kind of avoid the word AI. I avoid the tool. I look at the impact. I look at the ways that people can benefit from it.
Very good closing words. Sorry, guys, we are running out of time. Let me express my big thank you to you, because I tell you what, it was totally different to what I expected in a super positive way, because we haven't prepared so much, we haven't been scripted, and it was super interesting. And I tell you what, even not as an expert, I took so much out of it, and I'm pretty sure our viewers do the same. So thank you so much for being our guest here and share your knowledge and opinions with us. Thank you so much, guys. Yeah, ladies and gentlemen, it couldn't be more interesting, but I tell you what, we even go one step further. So after a short break of highlights, we have another fantastic presentation for you regarding the topic of AI, and I think the four of them will challenge the next speaker for sure. So stay tuned, enjoy the highlights, and see you in a few minutes.